Okay, today's date is 16th of July 2026. This is how to build a force field. How to build a force field. I'm gonna dwell on because there are kinds of force field, and you have electromagnetism force field. I'm gonna be specific, mathematically specific here. I'm gonna start with my. I always start with hypothesis. And it sounds kind of layman, but it's structural thinking. It's like but this is this is just how to build a force field. What is a force field? This is our definition. A force field creates a particular barrier between mediums. Usually, a force field a force field is a particular barrier, is a protective barrier. Yeah. Is That's my definition of it. A force field is a particular barrier. So it is a protective barrier. So that's what I'm saying. There are kinds of force field. There can be a electromagnetic force field, uh, electromagnetic force field, an EM wave, because that's what drones use. Um, so there's this fossil that I've seen that has a burst of energy. Basically, it works this way, and this is the implementation of it. It does the job scientifically, but it's no redundancy in it. But how it works is this: so you have you have a drone, and drone has electrical components. So it takes those electrical components and converts it into an uh, 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 a pulse of energy. And this basically, well, my definition is it takes electrical currents and convert it into magnetic radio waves. No, electronic magnetic wave, basically. Um, it takes an induced the drone has electrical components. Scientifically, I'm gonna use the terminology I not scientifically. You have an induced you have an alternating current in the drones itself, and the drones are flying. They have alternating current, AC current, that represents information in the drone. So I've seen the implementation. This I watched a video on the inventor of the drone talking about how the drone uses electronic, magnetic, uh, uses not a feedback loop, not nothing like that. Uses waves to takes the wave and convert to high voltage energy. So high voltage energy. But it is it's not electric. It's magnetic. So the energy is magnetic. So I'll say the energy is magnetic because it's a pulse. It's like a field. So it creates just to shoot because it's a pulse. You have to fire it, and you have to fire it while the doors are motion. So it's a pulse of energy that's magnetic. A pulse of magnetic energy, and this was interferes with the electric signal and disrupts the drone's movement. Because drone threats are real. They are real. So for me, I have to go into physics laws and describe this mathematically. But that was the analogy that I understood. Because it's a magnetic wave. It's when because it's a pulse of energy, it takes electrical current. Basically it generates electrical current. It needs electricity. It basically generates needs electricity to the electric charge basically in the machine, in the a lot of force field, so it's a barrier. You can say it's a protective barrier, or it's just a barrier. Can be a barrier. It's a barrier. So, no, so in the force field generator or the tool, it fires like waves of this kind of it fires it in waves. So so it fires it in waves. So it fires it in it fires it in waves. So fire it in transverse waves, which are electronic, which are electromagnetic waves, which I believe are electron waves, because I can't remember my science. But the alternating current, because the alternating current, it's what the it's what saver current is. So you can't have direct current because the DC is not used in housing, using DC is using everything because DC is not safe. Because yeah. So I'm gonna talk about different kind of pulse field or plasma. But the idea is mathematics. So I'm gonna write some math formula. So if I don't get anything, it doesn't make sense coincidence in kind of sense framework. Not that it's incorrect. If it doesn't make sense systematically, like how a system operates systematically, I'm wrong. So like I was saying, you have uh, you have waves. You have transverse waves. So you get something, you charge it up. You get electrical, you charge it up when you because the you charge because you have something and you convert that, take that electric energy and convert that into electromagnetic waves, or magnetic waves. So you have a charge of energy, and that's how force will work. Like, if you want to protect it against aerial drone attacks, you won't see the electromagnetic structure weakness. You see the drones fall out of the sky. Because we don't observe EM waves. You see the drones fall out of the sky, and that's why. So that's what's up. So I'm gonna try and improve the design. I'm gonna try and improve it. Because that's what I'm thinking about now. Is it the other one I like the one I've seen that's what America uses for their drone threats. Because drones are green threats, and when you have a drone with a bomb, yeah, you have a drone with a bomb. I'm gonna have satellites in my constitution, like radio satellites. Mm. Oh yeah. So I hope I'm right about how it works. Okay, I'm gonna watch a video now. So, Boeing plasma force field. How close are we to being a force field? Okay, sci-fi. Let me just watch the video. How close are we to being a force field? Okay, so here. Oh, well, because you can't see my screen. Yeah, so I'm looking about force field and I'm hearing something different. So uh,
Technology Laboratory, for example, is developing a missile stopping force field using supercapacitors, devices that store electric charge. The idea is that when faced with an incoming missile, supercapacitors could flood the outer shell of a vehicle with electricity to create a temporary but powerful electromagnetic field. The blast of electromagnetism would last for less than a second, but the hope is that it would be enough to repel objects. Officially, the team is calling it electric armor, which sounds less cool than a force field, but I'm not the one building it. And they have had success with preliminary experiments, but there's a long way to go, and the finer details of how it works are still a little fuzzy. But that's still more than we have for blocking radiation like laser beams. In 2014, a few undergraduate physics students did show it was theoretically possible, and they published their findings in the student run but still peer reviewed Journal of Special Physics Topics. They suggested building a shield out of plasma, which is the fourth state of matter, and it acts kind of like a super hot electrically charged gas. And using it to build a force field is a pretty good idea. Enough so that big defense companies are already looking into it. Now, we actually see plasma blocking radiation all the time in space. A layer of the Earth's atmosphere called the ionosphere is full of the stuff, and it blocks low frequency radiation like radio waves. So, if you made a really dense layer of plasma, you could potentially block higher frequency radiation like weaponized visible or ultraviolet light. And since plasma carries an electric charge, it can be manipulated with magnets. So you could use a bunch of those to shape your field. The problem is, if your plasma force field is blocking lasers, it's also blocking all other visible light. So, sure, you might be protected from the enemy spaceship, but you'd also be blind. To really build a force field that would make Captain Kirk proud, we'd need to develop technology that could block both matter and radiation, all without totally disabling the crew. And right now, that seems a long way off. But maybe someday we'll get there. Thanks for watching this episode of SciShow, and special thanks to patron Nathan Hebert for asking the question. If you have a burning science fiction is amazing. Although the technology force fields, for example. We may never be able to build ones as perfect or impenetrable as you see in movies, but we might be able to make something pretty close, and some teams are already working on it. The details vary depending on the series, but typically force fields, sometimes called energy shields, are nearly invisible barriers that block matter and radiation. They can be used to protect a spaceship from lasers or cannons, or just to confine a prisoner for a few hours. But in the real world, most teams were categories. Fields that block matter to protect military prisoner for a few hours. But in the real world, most teams working on energy shields are doing it to protect military vehicles. The research is broken into two categories: fields that block matter and those that block radiation. And surprisingly, we're actually making more progress on the block matter side. The UK's Defence Science and Technology Laboratory, for example, is developing a missile stopping force field using supercapacitors, devices that store electric charge. The idea is that when faced with an incoming missile, supercapacitors could flood the outer shell of a vehicle with electricity. But the hope is that it would be enough to have had success with preliminary are still a little fuzzy. But that's still more than we have for block matter and radiation. They can be used to protect a spaceship.
Okay, so I've learned what the force field is here, and because it's scientific, so I just went and did the science. So there's a force field here, and this is how close are you to building force field? And I've heard it here. So I'm not just copying it; I'm educating myself.
The research is broken into two categories: fields that
That
block
block
matter
matter and
and
fields that
fields
block
that
potential.
block radiation. And surprisingly, we're actually making more progress on the block matter side. The UK's devices that store
What a superconductor!
the idea is that when faced with an incoming missile, supercapacitors could flood the outer.
Supercapacitors. I want to look at that. A supercapacitor or autocapacitor is a high capacity energy storage device that used to store electric energy through electrostatic electrical processes, both in the conventional and capacitor and batteries. A supercapacitor. So this is a capacitor here. Electrolytes. Focus electrode. Membrane. Collector. I don't know what this is. Oh yeah, I get it because they work in water. They work in kind of water, and you know what I'm saying. Understand supercomputers with batteries. So they look at electrolytes. Oh, I get what I'm saying now. I just remember like a call barrister. Okay, so we look at precision falsehood. So how does uh force field work? Gravitational force field. Oh, okay. I'm gonna speak about the gravitational force field for a little while. Because I'm gonna speak about it for a while because I know what I'm saying. So let me just speak about force field. The problem with gravity is gravity does not have a net force. There's no net force for gravity. There's no you cannot bring gravity to a stop because it's something that attains mass. The more mass an object is, uh, the more mass an object has, the more mass uh uh, basically mass equals no wait gravity E equals mc squared. That's energy equals mass times the constant of gravity squared. This energy equals mc squared. But the problem with gravity is it's a pull. It's a pull. You have to negate to have a gravitational force field. You get a pull. You have to have a push. You have to be to come to push away from gravity. Because gravity pulls things towards the center. So the center of mass of the object is gravity. So the idea, one I'm hypothesizing is that gravitational pull, being to center of the object, a counter, a counter pull, a counter is a push, something that pushes you away. We need a system like a white hole. Okay, white hole pushes things away, but that's theoretical. So the force field, the gravitational force field we have to have a net zero. You have to find a, you have to invent a net zero system, like a system that can bring us to a stop. Doesn't matter this moment to do it. You have to, doesn't matter the object, you have to generate an energy wave because there's no graviton in the standard model of particle physics. Uh, is there a graviton? Is there a graviton? Let me just because I may be wrong. Is there a graviton? It doesn't exist. Yeah, yeah. So there's no evidence for it, but there's no experimental evidence uh, uh, of the graviton, quantum gravity model. See, for me, the force field, there is gravity, but not in this because you can. I'm saying it breaks when you have a model of graviton in the standard. It doesn't work. It doesn't work. Your math's wrong. So because there was this formula I saw, and this formula you can add a negative to the equation, and that will still work. You can still solve the equation. It's a physical equation. So if I want to build, for me, I can say to myself today, if I want to build a force field, and then read my force field books, my A level physics books. Um, kind of fun actually, because I already have the books everywhere scattered. But the idea of this gravitational pull, you need a push. You need to find what's the compute always a push. So you have to, which is very hard to do, because you need more energy, to counteract the effect of gravity. Because gravity, so the idea of this gravity is that it's kind of uh, like it pulls stuff down. It's like we know that it pulls stuff towards the center, but the more mass it has, so it creates an equilibrium. I had a paper on my overleaf. I wrote something about it. I can't remember what I wrote about the gravity. That's what I'm trying to recite. So there's this equation that I can't remember for gravity. So for like how it can be that gravity is emergent. No, gravity is not emergent. We have space and time. We live in a space-time universe. So we need gravity and time because of time dilation. Uh, Time dilation, which is defined as changing. See, basically, time dilation is a space-time graph. That's what time dilation equation. Einstein's theory of relativity. Yeah. So time is relative. So you have something that negates time. So you have something that works. It used to be a exact amount of matter. Something that works in exotic matter. So let me just find it here. So this is the idea of it. Need exotic matter to counteract the behavior of gravity, and that is why I'm saying gravity is a unistable isotope. So time dilation is a phenomenon where a clock moves relative to observer, and in gravitational precession slows compared instructional clock. So this is a time dilation. Change in time equals change in time between prior to Ross here. I said the terminology right, but I'm talking about force fields too. So let me just find the document. So why time behavior at high speed? Yeah, time dilation. Yes, this is Britannia. I love Britannia. So time dilation is a theoretical special relativity. It's not just special relativity; it's the truth. It's the truth. So basically we need three equations here. So I'm gonna write down three equations. I'm gonna give you example because you need to make things to have quantum to have gravity. You have gravity, yes. Gravity is there. So gravity is defined as energy equals mass times mc squared. This energy equation. So if you want to rearrange this equation, energy equals mass times the ratio, the constant gravity squared. So I'm gonna take it under E equals mc squared. That's my first equation. So I'm gonna try to solve this problem here. And we have a time dilation. So time dilation is defined as it's a special relativity because it works in a special relativity. Yeah, this is what I'm saying. So two identical here, T prime, two identical clocks and alpha clock. This is a T prime equals T divided by square root of T, 1 minus T. Basically, there's Lorentz factor. Lorentz factor. Lorentz factor. So this Lorentz factor, the Lorentz factor is given as dimensions quantity. Yeah, dimensional quantity are ratios. So one over uh, they are they are they are they are ratios. So they are fractions. They are always expressed as function. Uh, Close to speed light from to the square root. So this is a dimensional quantity. So this is Lorentz factor. Uh, Gravity is not faster than light. to entertain is time dilation and length contraction. I'm looking at these papers, I'm not even like reading them. While gamma is the length factor, the motion quantities, v is the velocity of the object, c is the speed of light. Oh, c is the speed of light. So E equals energy equals mass times the speed of light squared. So this is wrong. Energy constants. Am I referring to two systems? Okay, so I'm gonna speak about these things better. Lorentz transformation. Initial frame of reference. So this time dilation. So yeah, you have to affect time itself. Because if time works in running opposite direction, you know. Oh yes, okay. Let me try to give you the problem formally. So the problem with gravity, I'm gonna do it now, guys, is that there's three main problems with gravity. Or having the force field for gravity, having a bring ground to a stop. There's three main problems. I'm gonna try and define here. Three main problems. Three more hypotheses. One, neutrino, neutrino, which are measured, which are measured on the which are detected uh uh basically the first problem is that the neutrinos have mass. So do they have mass? No, they don't. What is the neutrino property now? Did you remember? Okay, so the problem is that neutrinos are out of space and they're related to the spatial. Basically, when you neutrino, basically there's something in the system. Neutrinos and gravity are related. So gravity, I can't remember what I'm saying about neutrinos. I think I can write an article on this, but neutrinos are involved in these problems. Neutrino meaning because they interact with gravity. A neutrino is an electric particle that is electrical neutrino and has small mass, very small mass. Neutrinos are classified as fermions, but most abundant mass in the universe. There are three types of neutrinos: electron neutrinos, muon neutrino, tau neutrino. Each association of a neutrino is with a charge of neutrinos interact through weak forces and gravity. Yes, making them difficult to detect in and matter. So yes, I'm right. So neutrino. So I remember neutrino. So basically, if I remember this, because I do what I'm saying. So so neutrinos interact with matter, and because they interact with the gravity, and because they interact with gravity, there's a weak force through the weak force and gravity. So they interact with the weak forces, which are electromagnetic forces, strong forces, weak forces, subatomic world, reactive decay, power plus nuclear fission. Uh, uh, Wait, am I right or wrong? Is radio waves weak forces? Uh, Weak forces, no, weak nuclear forces. Yes, electromagnetism is a weak force. The strong force is gravitation because they are. Yeah, so the neutrino problem. The first problem, I'm trying to define it properly. Basically, I will not in this video so I define it properly. So the first problem we'll define is that neutrinos have mass, have mass. And when you are at when you are at a pole, whether it's north, east, south, or west, when you are an electromagnetic pole, they get stronger. You get stronger. But neutrinos come from space, so they smash into the earth at light speed. And the way to detect them, basically, there's a way to detect the neutrinos having mass. So you have to capture the neutrinos at a pole. And the pole I'm talking about is the electromagnetic pole, or induce, obviously, to reverse the current, you have to have an electronic electronic charge, um electronic muon, or a muon. Basically, you're gonna have electronic magnetic muon, um, uh, electronic magnetic neutrino in a field. So you have to set up a system, and that system is like a field, so you can repel, counter the force of gravity. But neutrinos are heavily involved because they're electron particles. So the neutrinos are something that I love to work with. A bit more, but because they interact, because um, uh, they do interact with matter. So you want to induce, yes, I remember. You want to create an alternating current system, AC system, that induces a neutrino on a pole, on a kind of a rotation, on an orbit, in orbit, in an electromagnetic field. And you want to convert that field to some kind of stable plasma. Stable plasma. Stable plasma. And this plasma will be representing the field of radiation. This field of radiation that can that can conduct. Basically, I'm giving the whole down. It can be used to conduct, or uh, uh, or basically, I'm saying the way I conceptualize it. I'm not just making this up. I'm making it from my own best understanding of the world around me. But neutrinos have mass, and they do fall at light speed. They do, because they come from space. They come from a comet. They interact with our poles, the Earth's magnetic poles, and the Earth's magnetic poles have a north and a south and pole. So you're gonna have, if you have to have electromagnetic system, and that electromagnetic system is gonna work like by separating the positive from the negative. So you want to have two sets of charge. So you're gonna have to build some kind of a conductor of the neutrinos itself electronically by making them separating the system. So you can can create an anti-system for gravity, because you can create a system of gravity. So you have this is a battery. It can be in a superconductor or a conductor of electrolytes that ensures the polarity is oriented away from oriented to a system, to away from gravity. So you counter the effects of gravity. And that's the 3 steps. So there are 3 steps to it, and there are 3 main problems to it. So the main problem is that you have to have neutrinos and weak force of gravity interact with only neutrinos via the electromagnetic spectrum of the weak force and the weak force of the system. So because they're hard to detect, you have to use electromagnetic, and create a storage in a pulse, a pulse. You have to store the pulse in an energy field. So because they hit the pulse, because the poles have like a positive energy charge, you're gonna have like if you can see a magnetic field, this is how it looks like. Because the poles have electric induced one way, you're gonna have the poles. So if you have a north pole and a south pole, you can have you can have it light up something that's induced by electromagnetism on one pole, and that's how you detect a neutrino. And the neutrinos are, if you know that is there in that area, in that region of space, and you can use it to conduct because you just light up a bulb, so it lights up a bulb. So by lighting up some kind of a LED, you have known that you have interacted with a neutrino because you have detected neutrino. So because they induce a bulb without the electrical current, without no current, because it's in an electromagnetic field. And that's what I'm saying about the neutrinos. They interact with gravity and interact with the weak forces. So you didn't want to use that system to induce a current, induce a field of the field. So the problem with gravity is that gravity pulls stuff down. So if you have enough conductor, you can push away from an object, can push an object counter the weight of gravity in one system, can counter the opposites of it. Counter the system via an alternating current system, AC, not the DC, because AC is stable. So AC is alternating current. This like AC, this current system. Basically, you have a magnetic field, and you have them going in and out like they are like this. That's an AC like a butterfly wings, and you have the kind of circuit AC where you have parallel circuits, and parallel circuits have resistance. So you're gonna have Ohm's law, Ohm's law, R equals resistance in parallel, resistance in parallel. Oh, R equals R one divided by R plus one divided by R2 plus one divided by Rn. That's I sub n. So that's the idea. I'm not gonna give a finished take on this, but the electronic new nodes control the muons. But you have to treat it like a compass. Don't treat it like the poles. Treat the pole like a compass because they are the compass. So if you think like a north, northeast, east, west, you're treating like a cubit, Namdi. So you're treating like a compass ring cubit, and that's the idea. So the neutrinos are there, and they're very much when they interact with something, they create they leave electromagnetic charge, and they light up, they can light up a bulb because they induce current. Yeah. The you just build a system around it. So thank you for watching the video. So how does gravity work? So this is how gravity works in a nutshell. The problem with gravity, I wish I can test my hypothesis, but I don't have a superconductor. I don't have a laboratory yet. Yeah. So that's the idea. Yeah. So so neutrinos are particles. They're neutrons. They uh uh, uh yeah. This is why quantum field theory exists. Thank you for watching this video, guys.